What's up, Algebra 1? We've got another video here. This one's for section 11.2, and we're going to talk about box and whisker plots. Maybe you've seen one of these before. Maybe you've worked with them a little bit before. You can see an example one here. We're on page 367 in the binder, and up at the top of the page, you can see some information about what a box and whisker plot is. So this diagram here is a box and whisker plot. And what a box and whisker plot does is it kind of takes all the data in some sort of set of data. This one's about the annual snow depth at Mathsville Ski Resort. So every year they measure how much total snow did they get, and so maybe it's over the last 30 years they have all the data points for the snow that this ski resort got. And what this description does here, what this graph does, is show us the minimum and the maximum. So that gives us a good idea of the range of different annual snow amounts. And it also shows us the median. This little bar in the middle is the median. It also shows us something called the first quartile and the third quartile, which represent kind of the halfway points of the lower half and the upper half. So let's talk about what those 5 things I just mentioned are. We call them the 5-number summary, and it's the minimum, what we call Q1, the first quartile, the median, and then Q3, which is the third quartile, and the max. And just up above in the bullet point, a little bit above it, we talk about 25% sections. That's a really important part of a box and whisker plot, is the idea that we are splitting up the data into 25% sections. So there's 25% of the snow depths every fall between what looks like about 30 and maybe 52. 25% fall in that left-hand box there, 25% in the right-hand box, and then finally 25% on the whisker. So it just gives us a way of kind of organizing the data and seeing where most of the data points fall. So below this we see a list of test scores. And what we can do here is actually work on creating these 25% groups. You guys have probably found a median before. Here what we've got are, to figure out how many data points we have, let's just give it a quick count here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We have 22 data points. So if we want to find the median, maybe back in middle school you guys would cross off one on the left and then one on the right, and then another one on the left and then another one on the right. That takes a while, especially if you get a really big set of numbers. So what we want to do here is think about, all right, if I have 22 data points, well, halfway would be 11. So I'm going to kind of count 11 instead of all crossing off one at a time. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that means I'm going to have 11 on the other side. So right here is my median. Notice it's not a specific number, it's between two numbers. So to find the median, you would take the average of those two. Well, the average of 88 and 88 is 88. So that's going to be my median, 88. And then to find the Q1 and the Q3, what we call the lower quartile and upper quartile, or first quartile and third quartile, we're going to find just the median of the lower half and the upper half. So I know I have 11 numbers here, so to split 11 in half, I'd have to go 5 on each side. So here's 5 and here's 5. So that 82 is the median of the lower half. So that's what we call Q1, so 82. Then on the upper half, I do the same thing, 5 and 5 to get me halfway. So 91 is Q3. And those are my key numbers there. Obviously, we can find the minimum and the maximum. I'm going to see if I can erase this so I can actually see those numbers. We've got 45 and 98 are the minimum and the maximum. That was step 5 there. I kind of skipped a step here. So minimum is 45, maximum is 98. Let's go back to step 4 for a second. Find the difference between the upper quartile and the lower quartile. In other words, this is Q3 minus Q1. We call this the interquartile range, or IQR for short. So the interquartile range is 91, that's Q3, minus 82, which is Q1, and that is 9. Okay, so the IQR is 9. What it tells us is that the middle 50% of our data falls between those two numbers. So kind of the more typical values are between 91 and 82. And so they have a range of 9 there. Step 6 is to actually make the box and whisker plot. So the way to do that, let me get down there here, scroll down. Okay. The way we do this is we plot kind of big vertical lines at each of the 5 number summary numbers. So I'm going to plot my minimum at 45, and I draw a nice big vertical line. My Q1 is 82, so I got to kind of estimate where 82 is. Median, I need the median, that's 88, so that's about here. Q3 is 91, and the maximum is 98. So in order, this was minimum, Q1, median, Q3, and max. All right, now to actually make the box and whisker plot, we take the Q1 to Q3 and turn that into a box. So you give it a top and a bottom, and then you connect the minimum and the maximum with whiskers. So if you look at this box and whisker plot, we can see that the middle 50% is right here, way to the right. So middle 50%. That word up top says middle. I should probably rewrite that. The middle 50%. Okay, and so that gives you an idea. All right, well, the kind of typical, the middle group of people on these tests scored between 82 and 91. So we kind of see that because of those lower scores, like we had a 45 and a 48 and a 60, that makes those are outliers, which is what makes the whisker on the left a lot longer. Okay, so that was our first box and whisker plot. We're going to do a lot of these on the calculator too. We'll learn how to do that in class. Skip to the next page for a second. So on this next page, we have actually the same box and whisker plot that we just made. But what I like about this one is it's actually drawn right above the dot plot. And so you can see that our majority of our data here, or a good 50%, the 50% chunk of our data is right where that box is. And so the outliers over here make that left whisker longer. There's not as far out, like the outliers on the right, or the data points in those upper 90s aren't as far from all the big chunk in the middle, and so that's why this whisker on the right is a lot shorter. But you can see that kind of the data clumped together here in the 80s and in the 80s is what gives us the box where it is. Finally, at the bottom of this page, we have this little discussion about what are some of the advantages of a box and whisker plot and disadvantages. So with a box and whisker plot, we can read off the minimum and the maximum, and based on that calculate the range. We can use Q1 and Q3 to find the interquartile range, the IQR. It gives us a nice visualization of how spread out the data is. And we can also find the median from the box and whisker plot. Something we don't know, though, by looking at a box and whisker plot, we don't know what the mean is. We don't know what the standard deviation is, although, again, we can see kind of how spread out the data is. And we don't know anything about the actual number of data points that have been collected. If you're just looking at a box and whisker plot, we don't see that. All right, we're going to do one more page real quick, so turn to 369. On here, I want you to pause the video and just make a quick box and whisker plot. Problem number 1, you're given the 5 number summary, so just practice plotting those 5 tick marks on your number line. Looks like you have to actually put labels for the numbers here. And so try that out and then unpause the video. Alright, your box and whisker plot should look something like this. Make sure you labeled the tick marks. And right below it, we have our directions for making a box and whisker plot on the TI Inspire, which we will do together in class tomorrow. So thanks for watching. Have a nice day.